The Windjammer Pro is our newest design in the Windjammer line of brushless blowers.
It adds many new features over the current generation while adding previously non-standard modifications as standard options.
These new features expand the Windjammer Pro into new niches beyond the current markets, including printers, material transfer, fume evacuation, and air sampling. Applications which contain high heat, humidity, dirt, or require higher performance are all targets for the Windjammer Pro.
Just like many of our brushless products, the Windjammer Pro is manufactured in North Carolina, USA, inside our 111,000 square foot facility. At Ametek, we strive to provide the highest quality products. Vertical integration allows us to control the quality of our finished products, including the Windjammer Pro. The plant operates 8 different production cells, serving 34 countries and over 100,000 customers.
After parts come in the door, they are finished machined on-site to very precise tolerances. This helps to control our defect rate as well as ensuring that our motors are some of the smoothest running in the industry.
The factory has the capability to process motors, brushed and brushless, from beginning to end. From winding machines to magnetizers, every process is overseen by industry experts. The assembly process is completed by hand to ensure that the utmost detail is not ignored. The 5S process is visible throughout the facility.
Throughout the manufacturing process, the motor goes through a 2-step balancing process. This ensures minimized vibration and maximum reliability. At the end of the process, the blowers and motors are tested to prove compliance to our stringent quality standards. Test results are recorded and maintained through our quality process.
Products are then put through a run-in process and cycled to ensure their reliability when they reach the customer. The Windjammer Pro also features the next generation of controller architecture. It does not use the option card system, but instead these features are fully integrated into the controller. This enhancement makes the Windjammer Pro an even better fit in a variety of unique systems.
The Windjammer Pro was designed with configurability in mind. The availability of standard options ensures that customers get the exact model that they require. Ametek Engineering has designed a smart model code to make identifying a customer model easier for all. The model code also allows our customers to understand the options that are available in the Windjammer Pro family.
At this point, we will discuss the available options. We'll start with blower construction. Just like many Ametek blowers, there are 2 functional sides, the working side and the motor side. The bypass configuration isolates working air from the motor electronics. Motor cooling air is channeled from the outside to cool the motor and electronics, then discharged.
It is important to note that the working side of the Windjammer Pro is the same size as the current Windjammer. The mounting, intake, and discharge size and port orientation are all the same. The motor side, however, has grown slightly larger in diameter, roughly 0.35 inches or 9 millimeters. The dual-function blower is a very unique bypass model with the addition of slotted holes near the base of the working side of the blower.
If the working air intake is blocked, air is channeled in this path, providing a suction feature. If the working air discharge is blocked, air is channeled in this path, providing a positive pressure feature. With the addition of a couple of shutoff valves in the customer system, the dual function port can be used to inflate or deflate. The peripheral configuration is also a bypass model, but instead of air being directed out of the discharge tube, it is sent through slots around the perimeter of the working side of the blower.
The through-flow configuration channels air from outside through the motor and electronics, then into the working side of the blower. The most important difference is that in this configuration, the working air is slightly heated. This makes it the perfect choice for applications that require heated air, such as hand dryers. Also note that because the working air flows across the sensitive components of the motor controller PC board, this may not be a suitable choice for application which contains high humidity or dirt. The Windjammer Pro is currently not available in peripheral or through-flow configurations.
Blower input voltage is the next option. The blower's final location often determines the input voltage. The options are 110 to 132 volts, 208 to 264 volt, and universal voltage with common performance. Universal voltage with common performance is great for applications that are used globally. This configuration will provide the same pressure and flow performance whether you're in China, Europe, Mexico, or the United States. It enables our customers to purchase one model and use it throughout the world, eliminating any worry about differing performance.
The performance of this model has been greatly increased over the standard Windjammer, from around 800 to 1300 input watts. When compared to similar competitive models, the performance is much greater and also features higher efficiency. It is important to note that the performance of the 208 to 264 volt model would be higher than the universal voltage common performance model because the motor is able to be optimized to a smaller input voltage range. Also note that on models except for common performance models, performance will vary depending on the input voltage. That means slightly greater performance at 240 volts than at 230, and so on.
The Windjammer Pro features two options for the intake of the working air. The bell mouth option draws air in from atmosphere. The intake tube allows customers to attach a tube to the blower. As a side note, if the intake tube is not connected to an intake hose and left open to atmosphere, the flow performance will be reduced because of intake turbulence.
A new option for the Windjammer Pro is the ability to duct motor cooling air. The standard configuration is as shown. Motor cooling air is channeled in and out of fins molded into the motor side of the blower. In a dirty or humid environment, such as printing presses or welding fume evacuation, the customer can duct in cool, dry, inlet motor cooling air. This will keep contamination and moisture away from the sensitive electronics of the motor controller and prolong the life of the blower. In applications that are sensitive to heat, such as an electronics cabinet or process control environments, the motor cooling exhaust air can be ducted out of the system, preventing excessive heat from accumulating in the system.
The Windjammer Pro is available in three different flow configurations: standard, high, and ultra high. The performance curves shown depict typical conditions. These are meant to be used as a reference point. Note that each configuration also comes with a larger diameter intake and discharge. The Windjammer Pro is available in four different pressure configurations: 1, 2, 3, and 4 stage. Stages refer to the number of working fans stacked together. The more fans, the higher pressure that is possible. Again, this data is for reference only. Flow performance in combination with the number of stages will dictate the actual performance of the blower. Always refer to the individual blower data sheet for this information.
The Windjammer Pro features the same mounting pattern as the current Windjammer, but with more flexibility. It offers a total of 5 different mounting configurations: a 1/4 inch through holes, 1032, and a 1/4 20 US threads. We also have M5 and M6 metric threads.
For blowers operating in adverse conditions, the Windjammer Pro offers some options to increase its longevity. For conditions which have high humidity or contamination, a silicone coating for the motor controller PC board adds a level of protection. The next level of protection that we offer is to replace the steel components, including the shaft and bearings, with stainless steel. This, done in combination with the silicone coating on the PC board, provides our highest level of protection in adverse conditions.
The most configurable part of the Windjammer Pro is its ability to offer many options for controlling the motor speed. 5 different speed command options are available. In addition to these options, you also have the flexibility to configure how the blower reacts if the speed command signal is lost.
The speed command options are as follows: 0 to 10 volt DC, in which the customer supplies a 0 to 10 volt command to the blower, which represents 0 to full speed. The potentiometer option is a mechanical dial which acts as a speed command. PWM, or pulse width modulation, refers to a varying duty cycle signal which represents 0 to full speed. The wider the pulse width, the higher the speed command. 4 to 20 milliamp, in which the customer supplies a 4 to 20 milliamp command to the blower, which represents 0 to full speed. The final option is for a remote potentiometer. The blower supplies a 5-volt DC signal which can connect to a remotely operated speed potentiometer. In the event that the speed command signal is lost, the blower can be configured to react in 2 ways. Pull up means that in the event that the speed command signal is lost, the blower adjusts to maximum speed. This is particularly important in combustion applications where an air-gas mixture is being fed through the blower. If the speed command signal drops out, the blower must continue to push air through the system and not allow gas to build up. Pull down is the exact opposite. The blower speed will be adjusted to 0 if the speed command is lost.
Note that for these speed command options to be activated, the speed command signal must be disconnected. A 0 speed command will not cause the blower to pull up. Although there are several options, speed command is typically decided by the customer system. The Windjammer Pro's flexibility enables it as a drop-in replacement without changes to the system.
The Windjammer Pro also has the ability to run in 2 different speed control modes, open or closed loop. In a closed loop system, the speed command signal is correlated to a defined speed. The blower then works to maintain that defined speed. This defined speed is even maintained if the input voltage varies. For example, the blower speed will be maintained even if the input voltage drops from 120 to 110.
Open loop mode is the exact opposite. If a speed command of 5 volts DC is sent, it will pulse the stator at 50% duty cycle, regardless of what happens in the system. If the restriction pressure goes up, the blower speed will go up, and the opposite if the blower restriction goes down. The actual blower speed will be allowed to drift according to the load. There are a lot of reasons why either open or closed loop control may be needed. It depends on how the system has been designed.
The final and most popular modification to the Windjammer Pro is the ability to configure it with custom wiring connectors. The Windjammer Pro has been designed with onboard socketed connectors, which makes the use of adapter cables very easy. The following is a list of wire harness options. Depending on how the blower is used, each harness can be supplied separately. If the customer does not plan to use the status output, the harness does not need to be supplied. The wiring lead length is also configurable. Upon request, customer-specific connectors are also an option. The Windjammer Pro features many improvements as well as the integration of many custom features that have been developed over the years.
The most substantial of these is the redesign of the motor cooling chamber. The cooling airflow path has been completely redesigned and optimized to keep important electronic modules of the motor controller PC board cool.
The Windjammer Pro family features reverse cooling, in which the cooling fan draws air from the base of the motor assembly and directs it out the top. This ensures that the coolest air travels first through the highest heat generating components, such as the power module. This also increases the longevity of these temperature-sensitive electronics. The cooling ports have been moved to the side of the blower to prevent particulate from being sucked inside the motor assembly.
The reverse cooling in combination with the new scrolling design keeps air flowing and does not allow pockets of hot air to form. This new aluminum motor bracket directs cooling air past integrated heat sinks connected to the power module. Precision machined bearing seats limit vibration and make this a very smooth operating blower. The addition of this thermoset plastic housing acts as a barrier to prevent heat from the working air from being transferred into the motor side of the blower.
Other manufacturers use a single aluminum casting. Operation near seal pressure creates heat in the working side of the blower. Because of the great thermal conduction properties of aluminum, that heat is transferred into the electronics assembly by the one-piece design. A lot of consideration was made to isolate the motor and electronics assembly from the working side of the blower. The addition of this shaft seal prevents moisture and other particulate from making its way to the motor side, keeping the motor controller dry and clean. The motor bearing was also relocated away from the working side so that it gets the same protection with improved cooling. The combination of all of these improvements, as well as the ability to duct the motor cooling air in from the outside, makes this the perfect blower for dirty, humid environments.
Many of the customer-specific controller modifications that have been popular with the Windjammer family have been integrated and made standard options on the Windjammer Pro, making it the most configurable blower Ametek has ever offered. The addition of dip switches makes configuring the blower at the factory easy. This configuration will allow for decreased part numbers and the ability to stock units for a vast number of customers. The addition of error logging allows for blower errors such as locked rotor faults, overcurrent conditions, and other errors to be logged. This will make fault isolation and debugging much easier.
The status LED has also been included for a quick reference to the blower status. Note that the last 4 faults are latching, which means that the blower power must be cycled before resetting. A non-latching item will go away once the error is fixed. There is no need to turn the blower off.
In addition to the LED, the same status can be read on a digital output channel via the status output harness. A 15-volt signal will pulse using the same patterns as the LED, so the blower status can be read by the system.
Other improvements include a customizable TAC output signal. The standard TAC output signal is supplied at 15 volts DC and is configurable with 1, 2, 3, or 6 pulses per revolution, with the standard being supplied at 2 pulses per rev. To make the blower more robust, the inrush limiter was removed and now offered as an inline accessory. It is necessary to limit the inrush current in applications where the line voltage is used to cycle the blower. However, if it is possible, it is always recommended that the blower be cycled using the speed command signal instead. The blower also has the ability to reduce power to prevent over-temperature conditions, although this is not a standard option.
If the vast number of standard options aren't enough, our applications engineering team offers even more custom modifications, including custom ramp rates, custom speed profiles, custom current limits, and blower calibration. Blower calibration is a great example of the flexibility of our blower software. If the 0 to 10 volt speed control option is selected, this plot shows the typical speed command versus blower speed profile. You can see that the customer system is limiting the maximum speed of the blower. Usually this is caused when the system resistance pressure gets too low and causes the blower to draw more current. This rise in current is then controlled by the internal electronics of the blower, causing a knee in the plot.
In this example, the limitation causes 4 volts of uncontrollable range. To increase the controllable range, the blower can be calibrated by Ametek's applications engineers. To give the customer higher resolution of their control, that is RPM over command voltage, the plot can be linearized, yielding 0 speed at 0 volt command and maximum speed at 10 volts. Any other speed profile calibrations are also achievable through custom tuning. If the customer has a speed control dial with multiple positions and needs each dial position to equal a specific blower speed, the speed versus speed command profile would look like this. As you can see, the combination of application engineering's knowledge and the flexibility of the Windjammer Pro's architecture makes almost anything possible.
Please consult with Ametek as to the availability of specific configurations. Standard models will be rapidly available, while less popular models may require additional engineering and lead time.